So, my dear students, hope you are quite very well. So, our topic of discussions of today's class is chemistry in everyday life, and this subject is very important for MCQ type questions, basically in very competitive exams at +2 levels and in any entrance exam in chemical, in engineering and medical field. So, first we are going to look the uh, compounds used in medicinal chemistry. So in everyday life, we in present day life, our present day life basically depends on the medicines. So we have to have a clear understanding on the medicines we are using in our day to day life. So medicinal chemistry, first medicinal chemistry, first medicinal chemistry. So in medicinal chemistry, first we are going to discuss about antipyretic. 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 So what are the antipyretic? Basically, antipyretic are used to diminishes the high temperature of your body. That is, it is the medicine used for fever. For fever, used for fever, and for releasing, for removing high body temperature. So these are the antipyretic. So what are the examples of antipyretic? The examples are like this. These are some antipyretics. These are some antipyretic. This is the benzene, the OC2H5, in here NHCOCH3. NHCOCH3. This is called phenacetin. This is called phenacetin. This is called phenacetin. Okay, and very common antipyretic now. Very common antipyretic is paracetamol. So what is the structure of the paracetamol? So the structure of paracetamol uh, is very much resembles with the structure of phenacetin. So this is the paracetamol. This is the paracetamol. Okay, so this is our paracetamol, and very important. This structure is very important for exam purpose and also for your common knowledge. And next, aspirin. All three types of antipyretic are very common and very important for exam purpose and your common knowledge also. COOH, O, COCH3. This is called aspirin. This is called aspirin. Aspirin is the derivative of salicylic acid. So this is 2 acetoxy benzoic acid. This is 2 acetoxy benzoic acid. This is 2 acetoxy benzoic acid. And what is the paracetamol? Paracetamol is the 4 acetamidophenol. This is 4 acetamidophenol. This is 4 acetamidophenol. Okay. So these are the main three types of aspirin. Now we are going to discuss the analgesic. Analgesic is actually pain reliever. So I am requesting my dear students, please write down the three names of the antipyretic. Now I am going to remove this. So after antipyretic, next example, that is B, is analgesic. Analgesic. So analgesic are basically two types. Analgesic can be of two types. First, narcotics, and then non-narcotics. First narcotics, and then non-narcotics. So what are the narcotics? So narcotics are sleep, producing sleep and unconsciousness. So producing sleeping tendency and unconsciousness. And unconsciousness. Producing sleeping tendency and unconsciousness. Okay. So these are the opium type examples of narcotics are the opium and marijuana. Opium and marijuana. These are the two types of mainly two types of or two kinds of narcotics. And in opium, what are the chemical compounds? The chemical compounds present in opium. Chemical compounds. What are the chemical compounds present in the opium? The chemical compounds present in the opium is morphine. Is morphine. Is morphine and codeine. Is morphine and codeine. Okay, in morphine and codeine. So these are the what are the type of morphine and codeine? Are they acid or base? These are called alkaloid. These are called alkaloid. So morphine and codeine. So what is the structure of the morphine? I'm going to write down the structure of morphine. So my dear students, you are requested to write down what I am writing on the whiteboard. Everything I am writing on the whiteboard. Please try to write down this. O, this is O, this is OH, and here a bond between this, and here actually a bond between this compound and here So this is the structure of morphine. This is the structure of morphine, very important structure. I am requesting my dear students to please write down the structure of morphine. This is the structure of morphine. Basically, this group is above the plane, is on above the plane. So I am writing it bold, and the OH group is below the plane. So I am writing in the dashed line. So what is the structure of codeine? Codeine and morphine are obviously almost similar type of structure. The main difference is the OH group. In morphine, this is OH group, but in codeine, it is OCH3 group. So what is the structure of codeine? I am writing here the structure of codeine. OCH3. So this is the structure of codeine. So the main composition of opium is morphine and codeine. If you have been asked what are the main component of morphine, the answer will be codeine and morphine. Okay. Next, we're going to discuss about the non-narcotics. Going to discuss the non-narcotics. Okay. So what are the non-narcotics? So basically, heroin, one of the narcotics, prepared from the morphine diacetate. So what is the chemical name of heroin? So what is the heroin? All are the narcotics. What are the heroines? Heroin is the morphine, morphine diacetate. So this is the heroin, is the narcotics. Without any uh, a prescription of any physician, you cannot buy these narcotics. Now we are going to discuss the non-narcotics. What are the non-narcotics compound? All these narcotics and non-narcotics are analgesic. Okay, so non-narcotics. So obviously these are not derived from opium. Non-narcotics, not derived from opium, not derived from opium. So what are the example of non-narcotic? What are the examples of non-narcotics? Ibuprofen. Look, ibuprofen, ibuprofen, comma, naproxen, 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 then diclofenac sodium, sodium diclofenac, sodium dichloro, dichlorofenac, sodium dichlorofenac. So these are the example of non-narcotics. So what is the structure of ibuprofen? The structure of ibuprofen, I am going to write down the chemical structure of the ibuprofen. The ibuprofen is CH, COOH, COCH3, uh, this is CH3 obviously, sorry, this is CH3, and here CH2 bond CH, CH3, CH3. This is ibuprofen. This is ibuprofen. And what is the naproxen? The structure of naproxen, few naphthalene like structure. So it is the derivative of naphthalene, so it is naproxen. CH, COOH, CH3, and here one group is present. This is OCH3, methoxy group is present. This is naproxen. And what is the sodium dichlorofenac? Sodium dichlorofenac is the structure of sodium dichlorofenac. Here are the CN, and here this is CH2CONA. This is sodium dichlorofenac. Okay, so these are the main three non-narcotics compounds used as analgesic. Okay, now aspirin. What are the I'm going to discuss the aspirin. So aspirin is previously discussed. Aspirin is the antipyretic. Aspirin is antipyretic. So next we are going to discuss aspirin in details. So when aspirin is used for aspirin is used for some painkiller, pain relief compounds, as well as antipyretic. So aspirin, it is used as antipyretic to reduce fever, to reduce high temperature of the body, as well as anti analgesic for pain reliever. So the main use of the aspirin is as antipyretic and as analgesic. So next, paracetamol. We have already discussed the paracetamol and aspirin. Only I am writing this. So how paracetamol will be formed? Look, starting from paranitrophenol, This is paranitrophenol. Treat this paranitrophenol with a tin in HCl and reduce the nitro group. If you treat this paranitrophenol with SN10 and HCl, the nitro group will be reduced. The nitro group will be reduced to NH2. So it becomes para-aminophenol. Para-aminophenol. It becomes para-aminophenol. Then treat this with acetic acid anhydride. It becomes paracetamol. NHCOCH3. This becomes the paracetamol. Okay, what is the name of the Para-acetaminophenol or 4 acetamidophenol or paracetamol. And my dear students, please write down the reactions involving the formation of paracetamol. Just two-step reaction starting from para-nitrophenol. Okay. So these are the some examples of the compounds used in our day-to-day medical uses, and in presence of these compounds, actually the medicines in previous days are composed of these type of medicines, this type of compounds basically. But today medicinal chemistry evolved in much higher rate. Okay, so some new types of compounds are also used in present medicinal chemistry or medicinal industries. So what are the what is the difference between antiseptic and disinfectant? So now, antiseptic, what is the antiseptic and disinfectant? So antiseptic and disinfectant. So although the role of the antiseptic and disinfectant are same, okay, to kill the microbes, but the place is different. Their working place is different. Actually, the antiseptic works on the your on a human or living body, on the living bodies, and disinfectant actually works on the non-living bodies. So it kills germs and microbes on outer outer skin of living bodies. It does the same on non-living bodies. So it works on the living bodies, it works on the non-living bodies. So our examples are furacin, examples of antiseptic: furacin, furacin, comma, soframycin, 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 furacin, soframycin. Okay, and some examples of disinfectant. So there are very different types of infectants are used. Mm, that is Lysol. In most of our household use Lysol. So how this Lysol will be formed? Lysol will be formed as soap with paracresol. Soap with paracresol. Okay, soap solution of soap with cresol. So what are the cresol? Cresol are the compounds, that is the toluene, OH group present in toluene. Okay, so cresol is the hydroxytoluene. Cresol is the hydroxytoluene. Cresol is the hydroxytoluene. Now CH3. This is orthocresol. This is orthocresol. Similarly, meta and para. This is paracresol, and another is the metacresol. So there are three types of isomer of hydroxytoluene. So these are the antiseptics and these are the disinfectants. There are many other types of disinfectants are present. Phenol itself is a disinfectant, and resorcinol. Resorcinol is also a disinfectant. You can use resorcinol. Resorcinol. It is also a disinfectant. This is OH and OH. Basically, the meta position OH. This is the resorcinol. So these are the all these are the example of disinfectants. Okay, so my dear students, you have learned something. I hope you have learned something out of this class. uh, in our next class we'll see some more important and some other examples of medicinal chemistry, as well as some compounds, some organic compounds basically used in our everyday life. So I again request my dear students to please subscribe my channel, and if you do have any queries, any asking, write down in the comment section. Okay, till then, goodbye.